Hello there. Today's speech will be about pain and what it is associated, nociceptors and how do they work, and lastly painkillers and the way they function within our organism. Suppose you are at the beach and you get sand in your eyes. How do you know that sand is there? You obviously can't see it, but if you are normal, healthy human, you can feel it. Pain is a sensation of physical discomfort when often due to illness or injury. The pain makes you do something. In this case, rinse your eyes until the sand is gone. And how do you know that the sand is gone? Exactly because there is no more pain. There are people who don't feel pain, and that might sound cool, but it is not. If you can't feel pain, you could get hurt or even hurt yourself and never know it. Pain is your body's early warning system to protect you from the world around and from yourself. Literally, as we grow, we install pain detectors in most areas of our body. These detectors are specialized nerve cells called nociceptors that stretch from your spinal cord to your skin, your muscles, your joints, teeth, and some of your internal organs. Just like all nerve cells, they conduct electrical signals, sending information from wherever they're located back to your brain. But unlike other nerve cells, nociceptors only fire if something happens that could cause or is causing damage. So gently touch the tip of a needle. You will feel the metal, and those are your regular nerve cells, but you won't feel any pain. The harder you push against the needle, the closer you get to the nociceptor threshold. Push hard enough and you'll cross that threshold, and the nociceptors fire, telling your body to stop doing whatever you're doing. But the pain threshold isn't just that. Certain chemicals can tune nociceptors, lowering their threshold for pain. When cells are damaged, they and other nearby cells start producing these tuning chemicals like crazy, lowering the nociceptor's threshold to the point where just touch can cause pain. And this is where the counter painkillers come in. Aspirin and ibuprofen block production of one class of these tuning chemicals called prostaglandins. Let's take a look of how do they do that. When cells are damaged, they release a chemical called arachidonic acid and two enzymes called COX-1 and COX-2, which convert this arachidonic acid into prostaglandin H2 that convert it into a bunch of other chemicals that do a bunch of other things, including raise your body temperature, cause inflammation, and lower the pain threshold. All enzymes have an active site. That's the place in the enzyme where the reaction happens. The active sites of COX-1 and COX-2 fit the arachidonic acid very casually, and there is no room to spare. It is in these active sites that aspirin and ibuprofen do their work. So they work differently. Aspirin works like a spine from the porcupine. It enters the active site and then breaks off, leaving half of itself in there, totally blocking that channel and making it impossible for the arachidonic acid to fit. This permanently deactivates COX-1 and COX-2. Ibuprofen, on the other hand, enters the active site but doesn't break apart or change the enzyme. COX-1 and COX-2 are free to spit it out again, but for the time that ibuprofen is in there, the enzyme can't bind the arachidonic acid and can't do its normal chemistry. But how do aspirin and ibuprofen know where the pain is? Well, they don't. Once the drugs are in your bloodstream, they're carried through your body and they go to pain areas just the same as normal ones. So that's how aspirin and ibuprofen work. But there are other dimensions of pain. Neuropathic pain, for example, is pain caused by damage to a nervous system itself. There doesn't need to be any sort of outside stimulus. Scientists go through discovering that the brain controls how we respond to pain signals. For example, how much pain you feel can depend on how much you are paying attention to the pain or even your mood. Pain is an area of active research. If we can understand it better, maybe we can help people manage it better.